Okay, which is a typical example of the three equations and three unknown system, linear system. Entonces, the most important characteristic of this system is que in each equation, one variable is missing. You see in the equation number one, is missing the y. And the equation number two is missing the x. And the equation number three is missing z. There's one possibility. There are no only one possibility. There are several possibilities. Is, for example, you take the equation number one and you isolate the x. And you take the equation number two and you isolate the y. The reason is because equation 1 and equation 2 have the same variable z. You express the x and y separately in two equations as a function of z. And now you plug in x and y into the third equation. Okay, now we get the one equation on the only one unknown and solve for z. And the answer is -1. Cool. Okay. Well, the rest is easy. When you have the z value get -1 in your hand, just plugging in z value into the equation 1 and equation 2, and you get x equal 2 and y equal 4. Therefore, the solution is the triple order x equal 2, y equal 4, and z equal -1. Well, again, we have the system, three equations, and three unknown. Okay. The first operation is basically elimination. You're subtracting equation 1 and equation 2. The reason is because the y coefficient in the equation 1 is -1. Coefficient in y in the second equation is +1. This is ready. It's opposite sign, ready to elimination. And you obtain the equation 4, que is the equation that do not contain y. No? Likewise, you pair equation 1 and equation 3. And you multiply the equation 1 by -3. Okay, now adding each other, and you get the equation 5. Okay, the equation again, we get the variable x and z and y is eliminated. This is super important. So you pair one couple of equations and you make a decision to eliminate the y, and the second couple that you pair, you eliminate the same variable. So you have in this moment a system of the two equations and two unknowns, super easy solving. Finally, we try to solving the system formed by equation 4 and 5 together. Elimination one more time. You take the equation 4 and multiplication by 2, no? In order to get the same coefficient and opposite side. But something weird happened. When you adding this equation after the multiplication, you get the contradiction, 0 equal to. That means that the system have no solution. Okay, this is a word problem. This problem is relatively easy. This problem says that Elsa, Karen, and Abdul sent a total of 103 text messages over their cell phone during the weekend. Elsa, okay, this is basically this sentence is expressed like equation, no? You represent E la que Elsa, K la que Karen, and A is Abdul. So the first sentence is E plus K plus A equal 103. This is my first equation. My second equation is say Elsa sent 5 more messages than Karen. I'm going to say this equation only include two variables. Elsa E is equal K plus 5. Now finally, Abdul sent 4 messages as many Elsa as Elsa. Four times multiplication. Entonces, Abdul A is equal 4E. Okay, entonces, what is the manipulation? So when you finish the setup of the equation, now the algebra. You see, you take advantage, for example, the some variable missing. Entonces now you, for example, you taking the equation that is incompleted, the second and the third, in which the variable, some variable is missing, and you, for example, isolate K. K is equal to E minus 5. Okay, entonces now, and the third variable already is isolated A. A is equal to 4E. Plugging in everything into the first equation in order to get one new equation that contains only one variable, in this case E. This is E plus K, pero K is equal to E minus 5, and A is equal for E. Now finally, combine letter divided by 6, in this case, E is 18. The rest is pretty easy. When you have the value of E, que es Elsa, you plug it into the equation 2 and 3, and you get the Karen and Abdul value. And this is the final answer. O sea, Elsa sent 18 messages. Karen sent 13 messages. And Abdul sent 72 messages. Wow, too much. The same situation is 3 equation, 3 unknown system, linear system. Now, for example, the strategy is you take the equation 1 and 2 together. Well, you're adding, not necessarily multiplication for anything. You're adding because the coefficient in the C is positive C and negative C, and it eliminates C, and you get the equation 4. Likewise, you pair equation number 1 and 3. But in this case, you multiply, so you need to eliminate the same variables as C. You multiply by negative 2. And when you multiply by negative 2, you get negative 2Z. And actually, we have in the equation 3 positive 2Z. Now ready for elimination, and you get the new equation without Z. So, but in this case, wow. Look, equation 4 and equation 5 are identical. Because I suspect something weird happened. When you try, suppose you don't know anything, you try to put together 4 and 5, you get 0 equals 0 when you multiply by negative 1, of course. Entonces, this is the clue to give me information that we have infinity many solutions. Okay, entonces we continue. When you have infinity many solutions, I suppose the solution geometrically is like a line in 3D. And to express the equation of the line in 3D, we need a parametrization. So you need to define one parameter. In this case, there are 3 possibilities: parametrization using X, using Y, and using Z. However, the solution of this problem parametrization with respect to Y, you suppose the Y is Y. So you need to express X and Z as a function of Y. This is super easy because in the equation number 4, you isolate X as a function of the Y. And you substitute this expression gets 2y plus 4 into the equation 1. Now x is no x anymore, it's 2y plus 4. 2y stay the same, however you isolate z. And when you isolate z as a function of y, you finish. We found everything. So now, how you express the final answer? The final answer is obviously infinite many solution. Any point in the solution is a triple order point, but it's infinity point. Entonces now x is 2y plus 4, y, just y, and z is minus 6y minus 7. Cool. Okay, this is another word problem. Teresa, Chan, and Justin served a total of 90 order Monday at the school cafeteria. Justin served, okay, this is the first equation. The first equation is t plus c plus j equal 90. T represents the number of Teresa served, C Chan, and J is Justin. Okay, the second equation is Justin served twice, 2 times, as many orders as Teresa. To say J is equal to T is the second equation. And finally, Teresa served 6 fewer orders than Chan. The equation that represents this statement is T equals C minus 6, because fewer is minus. Okay, we have setting the, or set out, sorry, the equation. Now the strategy for solving is one more time the substitution. You take the equation 3, and you solve for C, is T plus 6, and the equation 2 is already isolate J, plug it into the 2 and 3 into the 1, is t plus 6 plus j equal 90, and so for t is easy, one equation, one unknown. The answer is t equal 21. After you know that t is equal 21, plugging in and the expression in which j is isolated, is 2 times 21 is 42, and c is equal to t plus 6 is another equation 3. 21 plus 6 is 27. Solution is Teresa 21, Chan 27, and Justin 42.